Hello, hi student. This is Priya, your maths tutor, and once again, I welcome you all on my channel, Vidya Lee. So, in the last session, we have started exercise 9.1, right? Which we have already completed. Today, we are going to start exercise 9.2. Before that, we'll discuss the theorems related to exercise 9.2. So, the topic for the exercise 9.2 is perpendicular from the center to the chord. So let's have a look at the first theorem related to the same concept. So the theorem is the perpendicular from the center of a circle to a chord bisects the chord. If we'll take a circle, we have a circle and suppose the circle has a center O and here is a chord AB. Now, perpendicular drawn from the center of a circle to the chord. If we'll take this as a perpendicular, which is drawn from the center of a circle to the chord. This is the perpendicular and this perpendicular will bisect the chord. That is, drawing the perpendicular from the center on the chord will divide the chord into two equal parts. That is, AM will be equals to MB, right? Is it clear? So whenever we have a circle, we have a chord, drawing a perpendicular from the circle to the chord. That means at the point where it is intersecting, it is divided into two equal parts. It is bisecting the chords. All right. Now, the theorem 9.4, what is it? It's the converse of 9.3. Now, here we have given line drawn through the center of a circle to the bisect the chord is perpendicular to the chord. If we're taking a line from the center such that the line is bisecting the chord, then that line will be perpendicular. Okay. So if any line that is passing through the center and bisecting the chord, then that line will definitely be the perpendicular line. Okay. Wonderful. Now 9.5 we have equal chords of a circle or of congruent circles are equidistant from the center. That is, if you are taking a circle or two congruent circles, if I'm taking two congruent circles and the chords, suppose both the chords are equal. I'm taking two chords, AB and CD, and these two circles are congruent, that is, have the same radius. Now, what we have given, equal chords of a circle are equidistant from the center. If I'm taking a distance of this chord from the center and of this chord from the center, this distance is same. That is, if I'm taking O, O, L, M, OL is equals to OM, right? And similarly for the same circle as well. In the same circle, if we have two equal chords, then line joining the chords to the center are equidistant. That is, are equal. Okay. Line joining the chords to the center are equal in length. If the chords are equal, and this is a converse of 5.9.5. That is, herein we have the chords equidistant from the center. That is, chords has this equal distance from the center. Then the chords are also equal. Herein we have given that if the two chords have equal distance from the center, then the two chords are also equal. All right. Is it clear? Wonderful. Now, let's start the exercise 9.2. So the question number 1 we have is two circles of radii 5 centimeter and 3 centimeter intersect each other at 2 points, say A and B. And the distance between their centers, these are the centers P and Q, and the distance between the centers we have given is 4 centimeter. Find the length of the common chord. This is the common chord, right? And we need to find the length of AB, right? Let's see how we are going to find the length. So first of all, let's see what is given. So we have given two circles. First circle with center P and the radius 5. Second circle with center Q and the radius 3 centimeter. So we have the two circles. Circle C with center P and radius 5. C dash with center Q and radius 3, right? And they are intersecting at point A and B. Intersecting at points A and B, right? Now, this is if we'll join PA and AQ, these are the radius. So whatever we are doing from our side, that is the construction. So we have joined PA and AQ. Now just observe it, figure carefully. This is a chord, right? See, this is the chord and this is the center point. So we know that line joining to this from the center to the chord is perpendicular line, and that line bisect the chord, right? So herein that means we have angle PRA equals to 90 degree, right? We have angle PRA is equals to 90 degree and AR is equals to RB. Now we want to find the length of AB, right? And if we'll be able to find the length of AR, we know that AB is equals to AR plus RB, where AR and RB both are equal. So AB will be 2 times AR. So that is our main concern, is to find the length of AR, this part. Now, how can we find its length? If we know that this is making a right angle triangle like this, ARP, a right angle triangle, and another we have a right angle triangle, ARQ. So we have two right angle triangles and we can apply the Pythagoras theorem. We have this length 5 centimeter, we have this length 3 centimeter, and the whole length we have is 4 centimeter, right? If I suppose this is x, this will be 4 minus x. Now using the Pythagoras theorem, we can find the values of AR, right? So we'll use the same concept and we'll find the value of AR. Let's see how we are going to do this. So we will suppose first, let RQ is equals to x, as PQ is equals to 4 centimeter, and RQ we have supposed at x. Then PR will be 4 minus x. So PR is equals to 4 minus x, right? Now we'll take the first triangle, that is triangle APR. So in triangle APR, hypotenuse square is equals to base square plus perpendicular square. Yes. So that is, we have AP square is equals to PR square plus AR square. We want the value of AR. So AR square will be AP square minus PR square, where AP is 5 centimeter. So 5 square, and PR is 4 minus 6. So it is 4 minus 6 whole square, right? So let's solve it. So 5 square is 25 minus 4 square is 16. X square is x square minus 2 times 4 times x is 8x. And it is equals to 25 minus 16 minus 9 x square plus this, which is equals to 9 minus x square plus 8x. So this is the value of AR, but in terms of x. So what we'll do, we want in terms of numbers. So we'll take the next triangle, that is ARQ. In triangle ARQ, AQ square is equals to RQ square plus AR square. Again, we want the value of AR. So AR square is AQ square plus RQ square, where AQ we have is the radius 3 centimeter. So it's 3 square, and RQ we have supposed at x. So x square, which is equals to 9 minus x square. So that is the value of AR square. Now, equating equation 1 and 2. Left hand sides are equal, so right hand side are also equal. So using equation 1 and 2, we got 9 minus x square plus 8x equals to 9 minus x square, right? This 9 and 9 got cancelled, x square and x square got cancelled. So we got ax is equals to 0 or x we got 0. That is the value of AR cube is equals to 0 and PR is equals to 4. This is what we got. Now we want the value of what? We want the value of AR. So we'll substitute the value of AR in any of the equation 1 and 2. Put x equals to 0 in equation 2 to get the value of AR. What we'll get? AR square is equals to 9 minus x square, which is 9 minus 0. That is AR square is 9 or AR is 3 centimeter, right? Now we want to find AB, and AB we know is equals to AB is equals to 2 times AR, that is 2 times 3. So AB is 6 centimeter. Okay. So how we have solved the equation? First of all, we have given the two circles with center with radius 5 centimeter and 3 centimeter. Both the circles are intersecting at 2 points. We have taken the points as A and B, and the distance between the centers of the circle are 4 centimeter, right? Now we know that line joining from the center to the chord bisect the chord, and that line is perpendicular. So this is making a right angle, this is making a right angle. Using the two right angles, we have find out the value of AR. Equating that value of AR, we got the value of X. Substituting that value of X in any of the two equations, and we got the value of AR. Now, as AB is equals to 2 times AR, so AB is equals to 2 times AR is 3, 2 times 3, that is 6 centimeter. I hope it is clear to everyone. Wonderful. So we have completed for question number 1. So in the next session, we'll start the question number 2. So for that, stay tuned. Bye-bye. Have a nice day.